welcome to Jessica LADYADA.
Hey everybody, and welcome to yet another Sunday night with me, LADYADA, at
right.
my desk.
It's 2021, and
yes, it's a new year.
It's a different date on the calendar, but we're still going to do the same thing, and we're going to even do more.
Nothing's changed.
So that's what you can rely on us for. More engineering, more Sunday night, Jessica LADYADA. We're not stopping. We're not slowing down at all because we have to do this. We want to do this, and thank you for joining us this Sunday night. LADYADA, what are you doing this week?
Okay, well, we had a long weekend, which was really wonderful. So I actually got caught up on a lot of hardware bits and bobs that have been sitting on my desk, including a quest that I had for quite a while to make a Feather ESP32-S2. Every new chipset that we encounter, we create a Feather board. And ESP32-S2, you've seen it in the mag tag, and we have a Metro for it. So you're probably wondering, well, why didn't you make a Feather? And there's actually a pretty good reason why I didn't do a Feather till now, and I thought I would talk about it. So let's go to the overhead real fast, and let me show some things, and I'll bounce around. So this is the Feather shape, and it's 2 inches wide by 0.9 inches across. Being finicky. Sorry, 1 second. Okay, I got it. Sorry. Okay, so it's 2 inches across by 0.9 wide. My one regret in life is I should have made it 1 inch wide, but it's too late now. That's what I'm stuck with. And it's great for chips and boards with small modules like the NR52840, or in this case this is a Feather M4, and you see there's plenty of room for power supply and LED and buttons, and you even have some space over here. I mean, it's really the right amount of space for a development board with battery power, a couple of accessories, and you still have space for a silkscreen. I like it. And one of the reasons I made it a little bit wider than like the Metro Mini and maybe some other dev boards that you've used is because I want to make it easy for you to grab onto the edge and pull it off of a breadboard if necessary. And
just a couple side notes. We have, if you Google for awesome-feather or github.com/adafruit/awesome-feather, you can see all the different feathers. There's more feathers that we don't make out there, and then there's hundreds of feather wings, probably be in the thousands not too long from now. And just on like ancient history, untold history of Feather, I had emailed Arduino a million years ago and proposed this as a format for Arduino to evolve into with LADYADA, and didn't.
The maker did not exist yet at the time.
And they never got back to us.
Okay.
So that's where Feather came from. And so one of the things, just as a little advice for everybody watching, always chat with folks. Always say, "Here, I've got ideas," but never stop shipping hardware. And here we are.
And never get into a land war with Asia. Okay, so the Feather M4 is great. This is a one. There's even extra space here. I'm thinking about maybe giving this a refresh. And we did make a Feather ESP32. This is actually a Feather wing. I grabbed the wrong thing, but it shows you that one of the things that's a little sad is that this module is exactly wide enough for the Feather. Like you see, it goes right up to but doesn't touch the pins, but it's really close, and I don't really like how close it is. It's quite close, and we sell the Feather ESP32, and I love it. It's wonderful, and it's one of our most popular feathers. But when the ESP32-S2 came out, they didn't have the room size module. The module basically only came in this longer size, and the reason is that they added this little PSRAM chip, and basically they just sort of extended the size of the module. So now it would be this big. And basically when the module is this big, there's just no way to have, if you look at it here, you really don't have enough space for all the support circuitry you need, right? Because you have to route the pins underneath. You might be able to make it fit, but it's just like, it's just kind of not a great experience in my opinion. I wasn't excited about doing this because of the size of this module, which is why we did like the mag tag. And the mag tag is a larger board, and so it was totally not a problem to fit this big module over here because the size of the display was so large that we had like extra space. There's even space for like a battery. Like that wasn't an issue. But for the Feather to maintain that format, this module didn't quite fit. And so I was like, well, I'm just going to wait around and I'll deal with this problem later. Because that's my my method of dealing with stuff. And then the folks at Espressif came out with the mini module. And this is actually only available recently. In fact, this is like a top tip for people who are watching the show. If you go to my computer, these modules are in stock right now at DigiKey, and they will not be in stock by the end of this show. I've learned my lesson. I already ordered some for myself.
Ooh.
But there is
What did they search for if they want these?
ESP32-S2 Mini.
Oh, we're doing it again.
Okay, do it again. So it's the PCB antenna and the IPX antenna. Maybe don't buy them all out if you don't need them. But these are samples anyways. Okay, so back to the overhead. I'm only saying that because I already ordered them, so hopefully I'll get mine pretty quickly. So this module, what's nice is that it's so cute and compact. It easily fits onto the end of a Feather. There's even room for the silk screen. I love that. I love labeling every pin. It's got the same pins available. They're just more compact. And the reason it's able to do this, and I didn't decap this like I did this one because these are more valuable than gold. But inside is, these ESP32-S2 chips that have built-in flash. This is the S2FH4 series, for example, which this one I think even has RAM in it. But basically they made, this module has 4 megabytes of flash bonded inside the chip. It's a, system in package. It's got like the processor and it's got the flash in one chip. And because of that, you can cut off, this, it's basically this, but like without the flash and the RAM chips. It's like that, right? That's about how big it is. And so that's the mini module. So the mini module is finally available from distributors. And I was like, yes, I can finally design this Feather because I will pop this on and I have so much space, and I have space to like add like LEDs and a battery supply and like some accessories as well. Because I wanted to do a really nice job with the Feather ESP32-S2. This is awesome. I also wanted to be single-sided. The traces, of course, are on the bottom, but only the parts on the top. So the S2 mini module, by the way, doesn't have PSRAM built in. However, given that there's a chip version that has flash and PSRAM, I'm pretty sure there's going to be a mini with PSRAM as well. And if not, I'll bother Espressif until they do it. Okay, so that's where I started with. I was so psyched to see this module was available. So I had some time this weekend, so I designed a couple Feathers. So first up is just a plain Feather. So this is, thank you, gracious assistant. So a USB-C, you can't see my finger, battery connector, battery charging circuit. There's 2 buttons. There's one there's one like right here. That's the reset button, and then this is confusing. Over there, even more, there's the boot button. You can sort of see it over there. And then there's a NeoPixel. There's the 4 dots in the center. That's a vertical mount Stemma QT connector, so the cable plugs in from the top. Above that, I put an LC7090-203. It's a very low-cost I2C battery charge monitor. It's much lower quiescent current than having a resistor divider, although I could always just do a resistor divider if I want, although I think I was starting to run out of pins. And then all the way to the right is a BME 280. I basically had a little space left over, so I made a footprint that I could put, because I was thinking like, if you're going to have an all-in-one like Home Assistant node, I think it would just be a ESP32-S2 with a BME 280 or BMP 280. Because like humidity and temperature and pressure, those are the kind of things that people tend to measure with Wi-Fi. Like it's all-in-one, and then a NeoPixel. And you can see that there's plenty of space for silkscreen, and this is all a single-sided board, and it fits beautifully, and it fits wonderfully, and it's single-sided, and I love it. So this is, of course, I'll fab this and we'll see how it goes. But I'm pretty confident. There's, one pin's used for a little double-click detector, so you can double-click into UF2. But there's also the boot button if you ever want to get into the ROM DFU bootloader. Okay, so then I went and I revisited a project from 2 years ago Folks who watch the show know I love going back 2-3 years to finish projects that I started. So a long time ago, we wanted to make a PyPortal Mini. We had made the PyPortal, and it was quite popular. People really liked it. And Phil said, can you make a version that's just like an OLED and a PyPortal, but it's like really small, where it's basically a Feather plus an OLED put together. And I was like, yeah, sure, I can design it. But at the time, to make it work with CircuitPython, we had to use an M4 plus an ESP32, so it was like, a combo. And then the OLED, we didn't have these like little skinny TFTs yet. This was a couple years ago. Like they showed up a few months later. So the OLED is kind of like all the way there to the right, and it's kind of like overhanging, but it folds over the back. And I thought I'd maybe have some buttons or UI on the back, and then it would be like a Feather with an OLED. But like the more I worked on it, the more I was like, this is just going to be really expensive and stupid. I didn't really like the design so much. So I ended up kind of like leaving this be.
Right, but I want to point something out. So you were working on this back in 2019?
Yeah, this was right after the PyPortal.
Here's one thing. By the way, it's 2021, and I am going to probably continue to even give out more information about how we do things. So one of the things that I've seen happen over the last, I don't know, maybe 4 years, as especially Twitter has gotten worse, is people will say, I thought of something first. And it sucks for us because like we publish everything and they don't even read. And we'll say like, well, like you can see our show back then, like, we did this project. Here's our files on GitHub, their timestamp. Here's a date code on a PCB. And people assume like if they think of something and don't release it, and then they see something like it at Adafruit one day that we haven't already thought of or already did it. I personally don't think it matters who thought of something first. Do the best job. Come up with the best stuff, the best support, the best service, the best hardware. And this is open source, so it doesn't really matter. The whole idea is to build on top of each other's great work together.
What's interesting is that we carry for example, like, obviously we were going to eventually make a Feather ESP32-S2. Like, it would be weird if we had not. And like Unexpected Maker, we sell their Feather S2, and they said, well, I have a Feather S2, but like, if you're going to make one, I don't want to release it. And they said, no, like there's space for both. Yours has more RAM, more flash, you have like a built-in light sensor. There's reasons for there to be two Feather ESP32-S2s. I would always tell people, don't not release something because I designed something similar. Like really, there's always some differentiation that makes it worthwhile to have multiple versions of a design. You never know. And also like, you might have like a different use case. You might have lower power capabilities. You might have like different accessories that go with it. It might be a slightly different form factor. Really, just release your hardware. Don't not release hardware because I release hardware.
Yeah.
Or I'm planning to release hardware.
And
it's not a good idea.
Again, a little behind the scenes, there have been individuals that email Adafruit and say, I wish you wouldn't release so much hardware. Like, who talks like that? Why would anyone say that?
Well, early on, Phil experienced that I designed a board, and then someone said, well, I have a board that's really similar to that coming out, so I really don't want you to release your design. And so I said, okay, and I didn't. And then that person who asked me not to release my design it took them like a year and a half, and then they like never really supported it, and it just kind of like didn't work out. And I was like, I really kicked myself. I was like, why did I wait a year? I should have just released it. Why did I like wait for this person who, I liked them, but it was, there was no real reason to believe that they would do a better job than me.
I've never seen or heard about an industry where some dude emails a woman engineer and says, I wish you wouldn't release so much hardware.
I do get this email quite a bit.
Anyways.
All right.
And so we're going to release more hardware than ever. In fact, speaking of Twitter, I just tweeted, we have 17, LADYADA just sent off a panel of 17 boards. I just tweeted about it. 17 new products are coming.
15 new products plus two testers. Okay, so great. So then I was finally like, okay, everything came together. Because I've got these little TFT screens that we put on the Mini Pi TFT, and these are amazing. They're ST7735s or 39s, 240 by 135, and they fit perfectly on a Feather. I know this because I designed a Feather wing with the same display. It's the RGB TFT Feather wing, although I'm using the 160 by 80 version of that display. But this got upgraded to a 1.14 inch 240 or 135. So this is basically, it's funny. It's like, this is basically like a LilyGo board, but it's feather shaped because they came up with they've been doing like OLED and TFT ESP boards. And I still have space for the 2 buttons. One button's behind my monitor, but you can kind of see it. I've got the vertical Stemma QT battery, and then this is a double-sided design, right? Which I don't like double-sided designs, but in this case, to keep it compact, it was required. So this is the other side. So in this case, I flipped everything over, and there's a lot more space because the bottom doesn't have the connectors in the way the USB-C and the battery. So basically all those components that were on the other side, I flipped them over and rerouted them. But I did manage to keep the pins are almost identical. Obviously, there's TFT connector pins now, but the GPIO pins are identical. I still have a little spot for a sensor because the sensor doesn't have to be on the top because it's like humidity and barometric pressure, so it just needs airflow. There's the battery monitor, battery charger, regulator, and all the support capacitors and stuff. And then the TFT is kind of shoved up against the battery connector, which leaves the right end free for the Wi-Fi antenna. So that's good. So then Phil and I were chatting, and this is interesting because before I designed this, I said, Phil, should I put the TFT on the front or the bottom? And we sat there and we talked about it for a few minutes. Because on one hand, this is really cool if you put this into a breadboard, right? You put it into a breadboard, your TFT is on the top, you got the buttons, you get the battery and USB, and you're breadboarding. But what if you want to put a feather wing on top? And you're like, well, when would I do that? Well, maybe you want to have a LoRa node, right? So you would add a LoRa feather wing, and you maybe want to put that on top of the board. And also, what if you want to have more buttons for UI? So I had some situations where you may want to have something on top of the feather and then flip it over and the TFT's on the bottom. So I went back to the original design, and I kind of shoved a few things out of the way because I needed a couple more passive components for the backlight and such. And then I flipped it over to put the TFT on the back, and the TFT, the connectors fold under. It's taped onto the bottom, and then I put 3 buttons on the right, just a little bit like our feather wing, our OLED feather wing. We have 3 buttons. So D12, D11, and reset. And the reason I really like to have reset is because if you panel mount this or you have it in some sort of enclosure, you'll always need to reset or get into bootloader mode, which you can do with the reset button. So I like to have reset available. And then some people were like, no, I want 3 buttons for the UI. So I was like, okay, well, what if I put the reset button to the right? I don't know if this is going to work out, but I'm definitely going to send out this PCB, see how it goes, build it and try it out. And I can always adjust, I don't even know if this shit works, by the way. So we're going to try it, and I can always do a revision.
All right, so that's all the stuff you're working on now. And, there's an awful lot of JST connectors in there. There's a lot of
I thought actually I would show some stuff before I start talking about JST connectors. Can I go to go back to the overhead? I can show some other things I was working on. The computer. Yeah. So I also was thinking about we were talking about maybe having an ESP32-S2 Pi badge, because we had the e-ink. Maybe we would like to have a Pi badge version for if it's basically compatible with the Pi badge as is. And I started routing it out, and then I kind of actually realized I ran out of pins. Turns out that I really needed all the Feather the 7051 pins, the M4 pins. I used the larger package for the Feather, and I actually used all the GPIO. And it turns out I ran out of GPIO. I was only 3 or 4 low. I was basically running out, and so I decided one thing I could easily get rid of is I use a shift register for the button presses where I just clock in. There's a latch, clock, and data pin. Those 3 pins are extremely fast for reading in GPIO. Up to 8 of them, where you can chain them to do however many you want, but they do take up into 3 extra pins. So I thought, okay, I want to use an I2C expander. It's not going to be as fast, but it's probably fast enough. And I actually looked at 2 cool chips. So one is the TCA8418, which is kind of a neat chip. This is an 8x10 keypad adapter over I2C. It's it's a TI part. It's like really specialized, it seems, but it's I2CN, fixed address. You get up to 80 keys in a keypad, and it has like an IRQ, and it does all the pull-up stuff for you. You'll still need to put diodes in if you don't want to have keypad ghosting. But it's a very inexpensive and pretty cool little chip, so I'm thinking of maybe using this. And then the other chip I thought of using, I saw this on Nice Chips, which is a subreddit, which they have like weird chips show up once in a while. So I subscribe to it through RSS to get the latest cool weird chips.
Well, side note.
Yeah.
For those who kind of follow the big arc of online communities, Lady and I were talking about this. If you took a break from Reddit because it used to be garbage, they've gotten really good about moderating subreddits. They have really good code of conduct. It is a much better place than it used to be. And I wouldn't say that unless I thought it was true. So if you're like, you know what, I don't want that stuff in my life, and you had a bad experience there, dip your toes back in, because they tried really hard. They did it. Clearly there was a big mountain moved to make it better.
Yeah.
And so we're starting to see more stuff there because we're looking there, but also we don't see as much like tear down of people or their projects, or they post something up. And so that's good. So
Yeah.
I got to make sure, credit where credit's due. So go Reddit community, watch out for that broken window thing.
Yeah.
Broken window syndrome is a true thing. Online communities, that is.
Okay, and then this one, so the AW9523 is like this ultra low cost I/O expander, but it's also an LED driver with constant current control. And I thought this was neat because in this version, it has enough I/O because I need eight for buttons, and then I'd like 2 or 3 for other like things like TFT reset. And then I think there was one other thing I wanted, like a shutdown pin for something else that I could put through the I/O expander. And then it could also control the backlight, because the backlight is 40 milliamps or so, I think, or 45 milliamps. And this has like a high current, constant current driver. So I could like get rid of a transistor and a couple of resistors, which I thought was kind of cool. So these are 2 other chips that I made breakouts for, part of the 17 panel board. And as I was doing this, I was talking to Phil, and he was like, well, you're going to keep those connectors on the bottom. And I said, yeah, I really like JST connectors. We've got JST SH connectors here and JST PH connectors here. And I thought, I should tell people who want to make their own Stemma QT boards, how to get Stemma QT connectors, also known as JST SH, so they can pick and place them onto their project. Because you can get those from DigiKey, and it's a good skill to know.
All right, let's open that can of beans.
Okay.
Where in the world is that part I need? The great search with DigiKey.
Every single week on Desk of LadyAda, we do the great search with DigiKey, and Adafruit. LadyAda uses her engineering skills to show you how to find all of the things on the DigiKey website. We call it the great search. Now, I have a little video that I want to show later about Stemma QT, but why don't you kick this off?
Yes. So I thought people were probably wanting to make their own Stemma QT boards. These are boards that have these little connectors on the end. Or maybe you want to connect to our larger Stemma series, which uses the Stemma PH pins. And I thought, let's go to the overhead real fast, and I'll show what these look like. So, can we go to the overhead?
Yeah.
So on something like this board, you'll see I have these kind of large JST PH connectors. And if I have an LED strip, for example, I want something with high current, something with a big connector that can handle these thick wires. JST PH is great. This is a 2 millimeter pitch connector. It's very common. You'll also see it in batteries. SparkFun originally started getting li-poly batteries with JST PH connectors, 2 millimeter pitch connectors. And so they kind of became the maker standard. And so I started using that exact same pinout. And then other boards like the Microbit uses that same connector. So you can start to cross connect all these batteries, and it's become sort of a maker standard. So if you want to maintain that standard and have your stuff work within this community, or you want to prototype with these maker parts and then make your final product, these are really good quality connectors They're really great value, and they're really reliable. One thing I'll tell you to watch out for is I've seen folks use non-genuine JST connectors and they catch. They don't have this like really smooth click in and click out. So these are, they're firm. You have to like exert a little bit of pressure to remove them, but they don't stick. Like they don't end up yanking the wires out of the housings. And I've seen that if you don't get genuine JSTs. So, just watch out for that. Some of them are compatible, but they're not quite compatible. So these are the larger 2mm pitch. And then for the Stemma QT boards, we use 1mm pitch. Again, this is another standard SparkFun came up with. They're really good at, being the innovators in this market. And they said, let's make breakout boards that just plug and play and chain over I2C. I2C has become basically the standard for sensors. We rarely see SPI only sensors anymore. I2C, you can clock it at 400 kilohertz or up to a megahertz, and it's well supported by pretty much every platform on Earth. So having just power, ground, clock, and data over I2C works wonderfully for many chips like this BMP390 barometric pressure sensor. And again, they fit snugly. They don't come out easily, but they do with a little bit of a yank, which I really like. These are non-latching connectors. As long as you're cool with non-latching connectors, then I think JST, SH, and PH are wonderful. So the difference, SH, 1mm pitch, PH, 2mm pitch. Okay, there's other pitches too, but these are what you'll see a lot of. Why not just go for 0.1 inch pitch? There are XH series and other series pins that are 0.1 inch, but they start to get very large, right? Once you start getting past like 3 or 4 pins, you're like, wow, like this connector is getting really chunky. And if you're not carrying that many amps of current, these are much more compact, which will mean that your board doesn't start getting overwhelmed. Like if I had a connector this size on a breakout, you see it would start to take up, half the body of the breakout would be the connector, and it wouldn't be as slim and svelte as these wonderful JST SHs. So let's show off finding some JST SH connectors. Let's go back to the computer. Don't forget, if you want ESP32-S2 minis, they're in stock right now. Okay, so remember there's 2 kinds. Let's first go to the JST PH. And there's data sheets, of course, available for these. When you search for a connector like JST PH, you're going to get a lot of connectors and cables and like pre-assembled things. So again, don't forget to go here and then you can look at the photos to see if that's what you want. Yes. And these the PHs come in like, 15 position, 4 position. All the positions you want, and they come in, this is called the right angle, and this is called the vertical, right? So this sticks up off of the board, you plug facing down. They are keyed, which I really like. I think when I was younger, I used non-keyed connectors. I thought as a child, I spake as a child, and I soldered as a child, but now I use keyed connectors, and I no longer flip my cables around. If you see the obsolete, that's probably because it's non-RoHS versions. You'll probably want RoHS versions. And then, I use the 2, 3, and 4 pin the most. And these also come in through hole. The PHs come in through hole because they're large enough. And so if you're using a process where you need a high mechanical strength, these are quite strong and they're inexpensive. You can pop them in easily and wave solder them. For the surface mount versions, you'll notice that there's those big tabs on the side. If you solder them down flat onto your ground plane, you'll have pretty good mechanical stability. Not as good as through hole, but still quite good. So, use these. I like that they're available in, like every size. This is the through hole right angle, then there's the through hole straight version, 3 pin, 4 pin, all that good stuff. And, we use these again for anything that has to pass like an amp or 2 of current. You can also get the matching connector. Let's see if they link the matching connector. Oh, they do have jumpers. This is kind of handy. So if you want to just buy cables directly, they're linked from the bottom. So it's a jumper cable from JST. There's the mating products. So various types of housings that you can use, and then you can get the pins to make housings, or honestly just get the jumper cable, and then you're good to go. You can always cut the jumper cable if you want to solder it to some other device or connector. All right, next up, let's look at JST SH. Again, you want to go into the pin connector. In this case, we're going to go for the 4-pin because we want to have it work with our Stemma QT boards. And we want active. Click OK. And you'll see, yeah, there's pretty much, you can get vertical. There's 2 vertical versions here, and I don't quite know the difference. These look to be identical. TBT. Oh, you know what? Probably one is in a tape and wheel, and one is cut tape or something. So this one is vertical, so it points up, and it's a little tough to see, but maybe I'll show on the 360. Give it a moment to load. This is handy when you want to make sure that the connector is exactly right. Okay, so you can see that there are these solder tabs. So these are melted into the body. So you'll just have to have 2 big solder pads to keep these from pulling, because especially since you're going to be pulling up on the connector. To make sure that your footprint has those. It's in the data sheet. And you can also download CAD models, which I've been starting to use, by the way. I used to make all my models by hand, my CAD models. Now I actually download one of these, whatever is suggested, and then I might tweak it to kind of fit the way I want it to look. But the footprint especially, I really like having the footprint made for me, and then I can attach that to a schematic symbol I already like.
Okay, one quick question. Let me find it. Do they have JST connectors that you can clamp onto a ribbon cable and make your own custom cables?
That's a good question. I think that you're not going to find something like that. You're not going to find an IDC connector for this size. Sometimes, let's look back to the PH. This one, I think that this might be a crimp connect. You might be able to poke a wire into it. That's the best thing you're going to be able to do, because it looks like you can either, you see how there's no 3D model, but see how there's a little U here? I think you can use a tool, like a punch down tool, and you could poke wires in, and then as long as it's the right gauge, check the data sheet for the gauge, it'll grab onto the wire and cut through the wire sheathing. And it won't be a very strong cable. I wouldn't use it for long-term use, but it probably would be good enough for very basic work, or if it's enclosed and protected. If you yank on it, you could yank it loose. But for something that's protected and not being yanked, I think it's fine.
Okay.
This is as close as you're going to get to IDC, to be honest. Okay, so sorry, we were at JST SH. 4-pin. So if you are making a Stemma QT board, this is pretty much the part you want. I think it's got a little thing at the 360 if you want it. The photo. So this is basically the connector we use on all of our boards, and it's in quantity. It's going to be about 20 cents or so. We can get them in real, but they're really reliable. Pretty much had them on now tens of thousands, maybe 100,000 different boards. And, no failures, almost no pick and place failures either. And, they have many cycles of use. So far nobody's worn out this connector. So I really like it. JST, they make really good connectors. Check out the JST website. Also, if you want to see other cables and connectors that they make. So you can mix and match with, your existing design depending on how much current you need and the gauge of the wires you're trying to connect to. That's the great search.
And that's a great search with DigiKey, but we're going to have one little extra segment. We have a special video all about Stemma that we just did. So I'm going to play this and then we're going to...
Do you like this connector? Here's more about it.
Yeah.
What is Stemma QT? Stemma is an easy way to connect sensors and devices with no breadboards or hand wiring needed. A controller board can plug into a bunch of devices for fast building and prototyping. Stemma QT is the smallest Stemma connector, used exclusively for I2C communication. You get 2 power wires and 2 data wires. I2C shares the data wires so you can chain together multiple boards. Stemma QT is compatible with SparkFun Quick and Seed Grove devices using a JST PH2SH adapter, so you can use all the hardware you already own. Stemma QT is built into Adafruit Clue, MagTag, QtPy, and more. You can get building without any soldering at all. Stemma QT is built into tons of Adafruit sensors and devices. Just look for the Stemma QT logo on the back of the board.
And with that is a great search.
Where in the world is that part I need? The great search with DigiKey.
All right. I hope you learned a lot.
So that's our Desk of LADYADA for the week this week. All the shows are back on the regularly scheduled schedule.
I know.
So
it's a year.
we have
It's a happening.
Tuesday is Product Tech with JP. Wednesday is 3D Hangouts, Noah and Pedro. Wednesday is Show and Tell. Wednesday is Ask an Engineer. Thursday is JP's Workshop. And Friday
Scott's
is
back.
Deep Dive with Scott. So we're doing all this stuff.
How could you not be entertained?
Yeah. So check out all the things that we're posting. For those of you who are into the TikTok, we started doing TikToks over the holidays, and turns out it's pretty popular because people like looking at machinery pics. So we put a lot of our machinery
I
pics
don't
there.
dance though.
Nope, not yet. The machines do.
What?
Um,
Yes, they do. The
machines
machines
do.
dance to music.
And so we're doing all that. But anyways, that's our Sunday night. That's all the stuff we're doing right now. And thank you so much for joining us. We very much appreciate it. Everyone had some really nice things to say and comments in the chat. So our promise to you is we're going to keep doing this every single day. Every day, we're going to do this.
Not the video. The video is once a week on Sunday nights.
Right, we
but-
turn off the camera, but we do exactly what we're
Yeah,
doing
yeah.
right
We're
now.
doing the exact same thing.
It's exactly like this, but without the cameras.
Right.
Okay, later, folks.
Bye, everybody.
Bye.